Okay, we want to find a rectangular looking application, so we want to find the largest rectangle possible in the fence. Now a rectangle, we've got 80 meters of fence and we want to find the dimensions which make the area as large as possible. So we don't know one side, so we can label that X. It's a rectangle, and we don't know the other side is Y. But what we do know is that the perimeter is P is equal to 80 meters, isn't it? And that would be 2 lots of X plus 2Y. Divide by 2 all the way through, and that gives X plus Y equals 40. That's our first piece of information. We also know that the area is equal to X times Y, and that's number 2. So the area then, which we've labelled A, is equal to X times Y, which you can write as 40 minus X. So that tells us what the area is as a function of X, is 40x minus X squared. Now that's a curve. We can find out when the area is maximum or minimum, can't we, if we differentiate, just as we've done before. So dA dx then, differentiating, 40 minus 2x, let it equal 0. And that tells us that 40 is equal to 2x. Move the 2 from time to divide, and we see x is equal to 40 over 2, which is 20. So x is 20. Now is that a max or min? Hopefully it's a maximum. So let's have a look at it. d2a by dx squared, the second derivative. Differentiate again, we get minus 2, which is negative, isn't it? When this goes to 0, this goes to minus 2. Negative. So max when x is 20, isn't it? Because it's always negative, so it's going to be minus 2 or negative at x equals 20. When x equals 20, what does y equal? 40 minus 20. And y is equal to 40 minus x, which equals 40 minus 20. So that tells us that y is equal to 20. So the square, the 20 by 20 square, is the maximum area, and the sides would be 20 by 20. So the maximum area in this question, which maybe I forgot to write down, so the area when it's a max is 20 by 20, isn't it? So it's 400 meters squared. Okay, let's put in the next question now. We got a cylinder here. I'll try and draw it as best I can. And it holds a volume of 128 pi centimeters cubed. Find its dimensions so that the minimum amount of metal is used in its construction. So in other words, find the minimum surface area. So we need to find minimum surface area of a cylinder, given that the volume is that. Find the dimensions. Okay, so we've got a closed solid circular cylinder. Okay, so we'll label it as R and of height h. The volume of a cylinder is pi r squared, the cross-sectional area, times the height, that's the volume. Now we know that's equal to 128 pi. So r squared h then is equal to 128 volume. Now the surface area, which we can write as A, is equal to, now you think of pi r squared as the area on the top, and there's also another on the bottom, so that would be 2 pi r squared plus, now the circumference is pi d, isn't it, or 2 pi r. So that would be that length there, but if you unwrap the can, unwrap it down here, say, you'll have a rectangle. This will be the length of one side, 2 pi r. And then the height of the rectangle will be h. I hope you can see that in your mind's eye. So there's the formula. Okay, so that's the area, and we want when the surface area is a minimum. Instead of writing it as area, I'm going to write that as S subscript A to denote the surface area. So let's get S subscript A as a function of one variable. So we can get rid of h, can't we? So s subscript a is equal to 2 pi r squared plus 2 pi r times h, which is 128 ch over r squared. So that surface area will be 2 pi r squared plus 256 pi over r. Differentiate then. dsa dr. Differentiate. 4 pi r. Differentiating with respect to r now. Plus, and this is r to the minus 1, which we could write it as here. So that'd be r to the minus 1. So that'd be minus, using the power rule, 256 pi times r to the minus 2. So let that equal 0. And what do we get? Well, that tells us that 4 pi r, move this over the other side, is equal to 256 pi. And then I'm going to write this as over r squared like so. Okay, the pi's cancel. This is an r, by the way, here. Might not look like one. The r squared can come up together with the other r, and the 4 can come down. So I'll use a bit more room here. So we get r cubed, because the r squared came up. 256 over 4 is 128 is 64. Cube root that. R is positive, so it's cube root of 64. The positive one is 4. So that would be r. H would be equal 128 over r squared, which is 16, which is 64 over 8, which is 8, isn't it? So h is 8, r is 4. Now, is that a minimum or a maximum? We need the second derivative here. So I'll put it up here. d2sa dr squared, then differentiating this. 4 pi plus 512 pi r to the minus 3, isn't it? Which is equal to 4 pi plus 512 pi over r cubed. When r is 4, we're going to get over 4 cubed. That's a positive, so min. So this would be the minimum. And the total surface area then, if we go back up, when r is 4 and h is 8. Where's the surface area gone? Here it is. So when r is 4, we get 16, 32 pi. And we get plus 2 pi RH, 4 times 8 is 32, plus 64 pi. So it's 2 times r, 8, 8 eighths is 64. 64 is 96 pi centimeters squared. That's the minimum surface area, isn't it, for the dimensions of this? So that's what we need to make it a minimum.